Okay, so now we're going to look at tangents to a circle. So a tangent is a line that touches the circle only once, like that. So actually, let's do this in a different color. Okay, so this red line is a tangent to the circle at the points 6 and 5. Now we figured out these 2 points in the previous question. We're just going to be using the 6 and the 5. Okay, so there's one of the points about a tangent is that a tangent is perpendicular to the radius. So my radius is over here, which is our R. And so if this is a tangent, I know that this is a right angle. Now, when we have lines that are perpendicular, this means that the gradients are the reciprocal of each other. In other words, if we find the gradient of the radius, we will be able to find the gradient of the tangent by simply flipping the radius, the gradient over. So in other words, if it ended up being 3/4, it would be minus 4/3, but we'll get to that. So what we're going to do now is we're going to work out the equation of this red line using the information that is given to us. So the first thing we can do is we can find the equation of the radius, because we have 2 points here on the radius. And using that, we can then get the gradient of the tangent. So finding out the equation of a tangent, the first thing we do, if we're given the center of the circle and a point on the circle, is we need to actually find the gradient of the radius. Okay, so the m of the radius. So the gradient of the radius is change in y over change in x. So we'll make this y1 and this y2 and this x1 and this x2. And so remember, our formula for gradient is y1 minus y2 over x1 minus x2. So we get y1 is 5, y2 is 1, x1 is 6, x2 is 3. And so we get 4/3. Now, the gradient of the tangent is going to be, because they're perpendicular, minus, because we change the sign. So in other words, if a line has a gradient of, say, 1/2, the gradient of a perpendicular line will be minus 2/1, which is 2. So what we do is we flip the 3 and the 4. And so we know that the m of the tangent is 3/4, but we also need to change the sign. Now that we've got the gradient of the tangent, we can use the other point to figure out the c, because remember, when we want the equation of a line, we say y equals mx plus c. So with our y, we can just use the point, because now we know that this point 6 and 5 lies on this tangent. So the y is 5. The m we now know is negative 3/4, and the x is 6 plus c. So 5 equals negative 18/4, which we can just say is negative 4.5 plus c. And so c equals, well, let's keep c on the side so I don't confuse matters, 5 plus 4.5, which is 9.5. So therefore, c is 9 0.5. And so the equation of this tangent is y equals -3/4x plus 9.5. And you can see that sounds right because this is all the way up here towards 9. 9 over here would be where it cuts the x-axis. Okay, so what are the important things we learned? So the first thing is that a tangent to the circle is perpendicular to the radius. And so if you know the gradient of the radius, you will then be able to infer the gradient of the tangent. And then you can simply use any other point on that tangent, which is usually the point on the edge of the circle, to figure out the equation of the tangent. And at the same time, if you're given the tangent and you knew the gradient of the tangent, you could then now work out the gradient of the radius.